Okay.
Well,
So this is the hardest case, I think. So the question is, when we take a 8 by 8 by 8 by 8 hypercube and we chop it into 1 by 1 by 1 by 1 cubes, what are the things that have 2?
well,
That's a pain on them.
what we could do is we could add these up and then subtract the sum from 4,096
Okay.
to find out how many of them.
To find out what the number is, and then that's a great idea actually, and then we'll try to figure out the interpretation of that number.
And what they are.
What they are. Okay, good. So,
We have 4,096, so we have to add 1,296.
all right. So here's my calculator. So I have 4,096 minus 1,296, 2,800.
Minus.
What's 6 times 32? Or sorry, 8 times 216. So I'm at 2,800. I better write that down.
8 times 216.
So 8 times 216 is so 2,800 minus 1,728. So I'm going to make that negative and go plus 2,800.
Okay, so that would be 1,072.
Sorry for the cat in the background. And then I have 6 times 32. So 1,072. So now I'm down to 880 minus 16. I'm down to 864. So the answer here better be 864. That's what we're looking for.
Yeah.
Well,
But the question is, what is it? What is it?
there's probably going to be an 8 involved. So we could take out an 8.
Why do you think there's going to be an 8 involved?
Well, there's been some form of 8 involved in all of these.
Except for 6 to the 4th.
Well,
Except for 0.
Actually,
this was 6 to the 4th, 8 times 6 cubed, 6 times 32, and 16.
64.
So, what even would have 2 here?
Yeah, so what had 0?
So it was
The
the
ones
inside of the
inside.
hypercube.
The inside of the hypercube, so that's why we had a 6 to the 4th. What had 1?
The faces of the hypercube minus the edges.
Okay.
And then
And so what shape were those
they
that we were looking at?
The hyper rectangles. They were sort of just the edges.
In the 3-dimensional cube, what had 1 was a square on the
Yeah.
inside, right?
Yeah.
Okay.
Oh.
So it was 1 dimension less.
Yeah.
Oh.
So
Okay.
these 8, the 8 was the faces of the hypercube, which are themselves cubes, like the faces here are squares. And then we had to go on the inside, and there were 6 of them. 6 by 6 by 6. So that 6 by 6 by 6 was,
Was the 6 was the
It was the
Yeah.
inside of the cube faces.
it was the inside of the cube faces. So we had a hypercube in the middle, then we had the cube faces.
So maybe something involving squares.
Okay, maybe something involving squares here.
Because we used lines here.
So we went 6 to the 4th, 6 cubed, something, 6 times something, and then 6, what power of 6 is here?
6 to the 0.
Okay, so the 864 probably has what in it?
6
squared.
A 6 squared, and it turns out it's 6 squared times 24.
Well, what do we have for 24 of? Well, maybe it's the cube, maybe it's the square faces of the cube faces of the hypercube.
Okay.
Square.
Well, let's go back to our dimension sliding again and see. In this case, we seem to be 2 dimensions down. Okay, so we got to see what's 2 dimensions down every time. Starting at 0 dimensions, what's 2 dimensions down?
-2. We can't say much.
Okay. With our line, what's 2 dimensions down?
-1 dimensions.
So we can't say much with the line.
Okay, so nothing. The square, what's 2 dimensions down?
The point.
The point. So we have 4 of them. Right?
Yep.
With a cube, what's 2 dimensions down?
The
Lines.
So we have
So we have 12 of those.
We have 12 of them.
yeah, 12, and then for the hypercube,
And by the way, what became the lines as we went from the square to the cube?
Well, you had. Well, the points sort of became the 4 new lines that you got,
Uh-huh.
plus these 4 lines you had before and the 4 lines in the copy.
Okay. All right, so what's my formula for how many lines? How did I go from 4 to 12?
So you took the number of lines you had already,
Uh-huh.
doubled them,
All right.
and added in the number of points.
Okay. So I took, now, but I have to be careful. I took what was 1 dimension lower here, the lines,
Yep.
and doubled it.
so
And
And
then
then added
what was 2 dimensions lower?
added the things that were 2 dimensions lower. So it's d minus 1 times 2 plus d,
D.
right? So d minus 1, so what became the number of lines on the cube? Well, it was twice the number of lines that I already had,
Yeah.
plus the number of points.
But your plus d, that would only be, you're in the second dimension here.
Oh, did I mean to say d minus 2?
Yeah.
Wait.
Okay, so I have a 2-dimensional shape here. I'm trying to understand what's 2 dimensions down.
From the cube, that would be the line.
Kind of lost track of what we're talking about. We're trying to find the number of lines on the cube, right? So
Yeah.
it's 2 dimensions down. So when I look at the thing that came before, I'm looking at the lines. So the dimension I'm looking for times 2. It's on the top and on the bottom. So the dimension I'm looking for, let's call D the dimension I'm looking for. Dimension I'm looking for times 2 plus how many things that were 1 dimension lower, because you slided those.
Yeah.
All right, or you slid those.
Slid.
All right, so now what am I going to do?
So
For the hypercube, I'm looking for 2-dimensional things on the hypercube. So what are those going to come from on the cube?
So those are the faces of the cube.
Okay, so what do I have to do with the faces of the cube?
So you'd have to you'd have to double the amount that you have.
And
Okay, what happens? So what from the cube creates 2-dimensional faces? The 2-dimensional things on the hypercube. What did they come from on the cube? Think about how the square goes to the cube.
Well, the 2-dimensional faces on the cube came from this, our square.
The square times 2. The
Yeah.
2-dimensional things on the square times 2.
and then
Plus
the
the number of 1-dimensional things that were sliding.
So
So sorry, on the cube we're looking for the lines. So the lines came from the lines times 2. That's what I meant. Plus the points. Lines times 2 plus the points.
so
So when we
here-
slide the cube and turn it into a hypercube, where do the 2-dimensional faces come from?
well, the faces
The faces.
times 2 plus the edges.
Faces times 2 plus the edges.
So that'd be 12 plus
Well,
12.
how many faces are there on a cube?
there's 6.
6. How many edges are there on a cube?
12.
Okay. So I get 24.
And then 6 squared times that.
Okay. So I do find 24. And why is it 6 squared?
Well,
Where is that 6 squared coming from?
because what you're looking for is on a square face of a cube face of the hypercube.
Yeah. Just like here, we had, if we pretend this was 8 by 8 by 8 on the square on the inside is 6 by 6. So there we go. So we got our formula. It's super, super messy, but let's write it out. It's 6 to the 4th, the inside cube,
Yeah.
plus the number of three-dimensional faces times 6 cubed, taking 1 off of each side,
Then it's,
plus the number of two-dimensional, these would be sort of the analogy of edges on a cube, but in this case they're two-dimensional edges,
yeah. So,
times 6 squared, times just the inside of those. Right, because they're 8 by 8, so we only need the inside because the outsides get counted next. These are the actual edges,
and
so it's 32
32
times 6 squared.
No, 6. Just 6.
6, sorry, you're right.
And then the points.
Plus the 16
corners.
points. So the formula for doing this now in any dimension, we've actually figured it out. If I asked you for how to do this in 20 dimensions, well, you look at the inside 20-dimensional thing, plus the number of faces, whatever that is, times 1 dimension down. Next up all the way down. And the way you find these numbers is just by looking at the pattern
From low dimensions.
from lower dimensions. And the formulas were actually pretty simple. It was always twice what came plus something else.
Really cool.
Yeah, this is cool. I think we'll have to repeat this project to make sure you understand it, but this is a very challenging counting problem, and you guys did a really nice job.